Okay, we're going to do a couple of word problems that are quite common that you'll see often. So the idea is we make an equation with rational expressions, and then we need to solve them just like we did in the last topic. So this first example I want to show you is we have Tom and Bill. They're 50 kilometers apart, and they're going to drive towards each other to meet. So Tom is going to drive 60 kilometers per hour, Bill is going to drive 90 kilometers per hour, and they're going to meet somewhere in between the two. So the question is where would they meet and how long it would take and those kind of things. So anytime you're doing one of these questions, what you want to do is you want to set up a chart. And in the chart, we basically track the distance, the speed, and the time. So you want to track each of those, and you want to put them in variables and so on so you know what's going on. So in this case, we know the total distance is 50 kilometers, but we don't know how far each person's going to drive to meet. So we'll say, let's suppose we call Tom's distance X. We don't know how far he's going to go, but we know that Bill's then would be 50 minus X, right? Because the total is 50 kilometers. So if Tom drove 20, that means Bill would have driven 30 or whatever. So they have to add up to 50 in either case. The speeds we do know. So Tom drove 60, Bill drove 90. And the last one, the time, is the one that we're always going to use in our equation. And the trick to do time, the formula for time is distance divided by speed. So we just write the two columns together. So you'd have x over 60 for time for that guy, and 50 minus x over 90 for time for that one. Okay, so once you have your chart filled out, the next thing is to make your equation. So like I said, you always want to use the time column because time is going to be the same for both, right? Each guy's driving a different distance, each driving different speed, but they're going to get there in the same amount of time because they're meeting in the middle. So in this case, you'd want to write your equation then as the time for Bill, so that's x over 60, and that has to be the same as the time for Tom. So we just write those two equations being equal to each other. Now we have our rational equation. Now we're ready to solve it just like we did before. So in this case, you want to make your common denominator. So I think it'll be 180 for both. So we just have to times the top to make it the same. So we'll times this one by 3. So that gives us 3x, and we times this one by 2. And make sure you times both things by 2. So that gives us 100 minus 2x over 180, and that's it. So just like we did before, we don't need to worry about the bottoms. So we just solve our top. So 3x equals 100 minus 2x. So to solve this equation, we would add 2x to both sides. So that gives us 5x equals 100. So the last step is divide by 5. So our final answer is x equals 20. Okay, so once you have your answer, now you want to go back to the chart to make sure you know what that actually means. So when we look at the chart, if x equals 20, that means Tom drove 20 kilometers because he was the x. So then Bill is 50 minus 20, which would be 30. And then we can also put them in the time part. So if we put 20 in for x here, we'd have 20 divided by 60, which is 1/3, so it's basically taking in 1/3 of an hour, or because it's over 60, it's 20 minutes. And if we do the same thing for this one, if we go 50 minus 20 over 90, that's also going to equal 1/3, which makes sense because they're both driving together, they're going to get there at the same amount of time. So if the question was how fast was Tom going, or sorry, how far did Tom go, you'd say 20 kilometers. If your question was how far did Bill go, it'd be 30 kilometers. If it says how long did it take them to meet, it'd be 1/3 of an hour or 20 minutes. So any of these questions, the chart is important to make because it'll help you figure out your equation, and then it'll also help you figure out whatever answer the question was asking originally. Okay, the next type of question that you're going to see quite often is, I like to call them a job sharing question. So this would be a question where it says, Bob can shovel his driveway in 30 minutes, and Ted can do the same driveway, but it takes him 40 minutes, so he's a little bit slower. So the question is, how long if they do it together? So we're sharing the jobs. We're looking at one person does it in 30, the other guy does it in 40, so how long would it take them if they both do it at the same time? So what a common mistake people do is they say, well, halfway between 30 and 40 is 35, so it's going to take him 35 minutes. But that doesn't make sense, because if Bob can do it in 30 minutes by himself, if he gets help, it should take less than the 30 minutes. And so what you want to do is sort of think if you had two people that could both do it in a half hour, so 30 minutes each, and two people work on it together, it should be 15 minutes. So we know the minimum then would be 15 minutes if they were both the same speed. Ted's a little bit longer, so it's going to probably, I'm guessing it'll take probably around 17 minutes or 18 minutes or something like that should be our correct answer. So how you want to set these ones up is you want to think of how much of the job they do per hour. So in X number of hours or minutes, in this case, Bob will do a 30th of the job. If it takes him 30 minutes to the job, that means he does 1/30th per minute. So if you do the total minutes divided by 30, that'll tell you how long it's going to, or how much of the job he gets done. And if you do the same thing for Ted, so X number of minutes divided by 40, so he'll do a 40th of the job per minute. And together, they're going to have to do 100% of the job. So as a fraction, 100%, we just can write it as 1. So that's pretty much how you want to set up these equations all the time. Okay, so when you set up your equation, like I said on here, we want to write it as x over 30 plus x over 40 equal to 1. And it's always going to be that format. Like it'll be the same. The only thing that'll change, instead of being 30 minutes and 40 minutes, it might be 2 hours and 3 hours or whatever. The reason we set it up like that, we think of Bob doing the job. He does 1/30th of the job per minute. So what we think of as the 1 over 30 as sort of being the rate that he works at, and then x in this case is the total amount of time it takes them to do them together. So what would happen in a question like this is it's going to give you sort of a percentage. So Bob, in this case, let's suppose he does 60% of the job, and Ted will do then 40% of the job, and then all together they do 100%. So you're sort of doing a rate times the number of hours that's going to take them, or minutes, or whatever the case is, equals the whole job. So that's how the equations get set up like this. It's kind of a weird setup, so you don't really need to remember so much about how it works. You just got to remember that it's always x over each of the person's times. So now when we go to solve it, the rest is pretty straightforward. So in this case, our common denominator would be 120. So write it as 120 for all of them. So we would times the first fraction by 4. So we'd have 4x would give us 120 times the second fraction by 3. So that gives us 3x, and times the last one by 120. So we get that. So now when we simplify our equation, our bottoms we could ignore. We just get 7x equals 120. And then we divide by 7. So x equals 120 over 7, which is 17.1 minutes. So you can see that our final answer is pretty close to what we estimated right at the start. So one guy can do it in 30 minutes. That means two people at the same rate would do it in 15. Because Ted's a little bit slower, it's going to take a little bit longer. So 17.1 minutes is the correct answer. So like I said, any of these questions, that's how you always want to set it up. So let's suppose I gave you a different one where it took one person 2 hours to do a job and the other person 3 hours. You just set it up as x over 2 plus x over 3 equal to 1. Always do it like that, and then it works out pretty easily to solve the equation. And that's it.